goes to the ejector plate and this guide pin piece of material in between them. And we start to hammer it. Go down. Or we need to put a thinner material in between. Okay, putting a thinner rocks in between and continue hammering. All the insert pieces. Here is the ejector pin, and here is the slot for the E clip or E ring, and I need to hammer this and flatten it a little bit, so when insertion into the ejector plate holder, this large end will be locked and cannot be pulled out from this direction. And I prepare this metal pieces. Just flatten it a little bit is sufficient. And this is the ejector plate, and here this is this side. I use another mold for demonstration, and I just insert the ejector pin from this side until the end, and I need to hammer it a little bit until this surface flush with this surface. And for the orientation, it should there is no specified position, but for my reference purposes, I will choose all the direction are the same. I use this direction, so every time if there is any changes, I can insert in that direction. And afterward, I will clip on the E-ring on this side. On this side, and then insert the E-ring on it. Make sure it sits on the pocket area correctly, and also lock this in the slot of the pin. The latch was assembled. These two screws here, this latch, and also that's the ejector plate. And since there are a lot of ejector pins to be inserted into holes, the alignment is difficult. So the hole on this side will be drilled a little bit larger. For this 3mm pins, I use 1/8 inch drill to drill into the depth of 1/3 of this depth, so the lead-in diameter will be larger a little bit. And so that's for the rest of pins, and it's a little bit tricky for the first assembly of this ejector plate on this lower half. And I think oil is necessary after assembly. Now it can be spring bred. Okay. Here I test the spring action, spring return action. I start to assembly. And for the upper part, this stripper plate was assembled with the upper half with two head screw, long head screw. Although this length of head screw is not quite correct, I first attempt to assemble it, and also it was tightened with another knob nut here. Then this mold was assembled. Here this cutout is for the midway for this screw head, and for this major part of this mold, it was complete. And now we turn to the rest of part of this mold, and here is an existing mold, and I need to borrow some of the parts from here to the new mold. This includes this ejector rack and this bottom housing assembly. This includes several parts. Here is the insulator plate. Why is necessary? Because there is heating element on the upper half, and those upper half and the lower halves are heat up during injection molding, and this insulator plate is to prevent the heat loss or heat dissipate from the rest of aluminum part. And also there's these two upper insulation plates in this part. You can see these are the bracket and the bottom plate. Here are the bottom plate assembly. And then these are the two cylindrical parts. These are the circular supporting pillow. It supports the lower half because the injection pressure is very large, or the clamping force is very large. It's during injections, it prevents the lower half plate from deformation, and it presses against it. And in ordinary large injection modes, this is a common practice. Some other small pieces. And it go to the upper side, and this one is the, as mentioned before, these are the insulation plate, and this one is the spur bushings, and molten plastic will be flowed into this spur and go into the runner. And another pieces assembly is here. This is the heating plate. There are heating element inside. This upper heating assembly. There is heating element here, two pieces. This is supposed to be a PTC, and there is two pieces of temperature sensor. These are the supposed NTC. So these are the rest of parts borrowed from existing mold to be assembled into the new mold here. And the previous mold is like this, and it is a simple 2/2 mold, and as mentioned before, the molten plastic come from here and go to the runner here and flow in through the gauge here, narrow gauge, to the cavity of the molding process. And then here is the ejector pin, and for the new mold, because I need to use this existing part, I cannot center this largest pieces in the middle of this mold, so I need to offset it. In this way, I need to use another type of runner. That is the pinpoint gauge, or this 3-plate mold. Otherwise, I can choose a simple method as the previous one, as 2/2 mold. Here, this area are flush. still the plate moves smoothly. Okay, turn to the upper half. As told before, these are the heating element, these are the temperature sensing element. Okay, two pieces. Here is the spur bushing. It's made of steel. And this recessed area match the spur of the injection machine, and this injection mold was assembled. The injection procedures, and my hand was not hurt by the machine. It's by my cat. She scratched my hand, and this mold mount on the injection machine, and electricity is connected here to the heater to heat up the tools, and temperature was sensed from this through this wire to the from the thermostat inside. Heat will be go through these three plates, but cannot go to the injection machine because it's stopped by this insulator, and also will not go to the lower mold half. There's this area because stopped by the insulator here. When the mold surface reach the temperatures, I think it's around 19 degrees or 100 degrees. I use this mold to mold plastic material of glass filled nylon. Is 13% glass fiber filled, so the mold surface temperature need to be around 100 degrees something. I don't remember. And when the temperature sense this mold surface reach the shaded amount, it stop heating, and the molten material will go through this bushing and go to this first spur, and go through this runner, and go to second spur until it fill up the cavities here, and then stop injection, and then cooling will start, and let it cool for some time, around 1 minute, a couple of minutes, and then until it solidify and cool down, the mold start open. First, it pull apart, and it pull apart. The mold open at first stage is here, because there is latch here to prevent the cavity and core plate separate. So this pull out until the screw head here stop by here, and continue pulling these two plates come apart. Spur will be detached out from here, and the runner will stick on this second plate because there is more force on this adhesion force on here, and then further mold opening, this latch will be open, and in this position the spur runner, the gate on here also detached, and the parts will remain on the cavity side, on the core side. We call this is core side, and this is the cavity side, and the spur runner and the runner is remain on this. Then we can take this out using some pieces or clamp to take this runner out, and the ejection will be started. And this a punch will be move forward in this side and through this rack and push the ejector plate forward, and then all the motor parts will be come out, and then in the next cycle the ejector plate will be retrieved, and then the mold will be closed again. The mold will be closed again, and the second cycle of injection molding will start. Thank you for your watching.